Hello everyone, today in this video we'll be discussing the super important questions of NCES, as well as we'll be discussing what are the key points and the diagrams are important, which are the numericals. Numericals will be discussed at the end of this video. So what I suggest is first you solve the theory parts, and if you just focusing on the theory part without any numericals, still you can score how many marks? You can score at least 70 marks, because the numericals will be asked around 28 to 30 marks. Okay, so even if you skip the numericals, it's good, only like you'll get the 70 marks without the numericals as well. So focus on the theory first, then if you get time you can focus on the numericals if you want, otherwise you can skip that. Okay, so here are the 5 modules. The 5 modules are introduction and solar radiation and all, then about the solar radiation geometry, liquid flat plate collector, wind thermal and tidal energy, geothermal, biomass and hydrogen. Okay, so the important questions which are repeated from the previous 10-year papers that I will be discussing in this video. And before getting started, if you like this video, hit the like button and don't forget to subscribe to my channel. Your support helps me make more videos like this. If you have got any doubt, you can ping me on Instagram. My ID is in the description box. And this file can be found in the link. There is a link called as 6SEM. In that there is a folder called as super important. In that NCES super important, there is a file called as with this name, so you can find this folder there. Okay, so anyways, I have mentioned the questions here, and the star questions are the super important questions. First you have to cover the star questions, then you have to go to the next ones. So what all you are supposed to write for this one, what will be the mark distribution, where you have to write the diagrams, and how do you explain the diagrams, how do you remember the diagrams, all the key points I'll be discussing. So let's get started. The first question, so the question I've mentioned in this way, like if I mention here star, so it's a must question, you must do it. Fine. What are the merits and demerits of conventional and non-conventional energy sources? So what do you understand by the term conventional and non-conventional? Conventional energy sources are which are available, like we are using those resources like the coal and all. Non-conventional are those resources which are renewable resources which are present in nature, like the solar energy or the wind energy, tidal energy and so on. So what are the merits and demerits? So let me tell you a few key points. All you have to remember is non-conventional energy sources are, see, I'll tell you what you have to remember. Non-conventional energy sources are freely available. Okay, freely available, and the disadvantage is that they are costly. They are costly to set up. Okay, these are only two advantages and disadvantages you have to remember, and rest you have to expand by own words. Okay, so if you go to the theory part, there is a lot of content and the time is very less. So what you have to do is you have to just remember the key points. I'll be telling the key points and you have to write the topics around it. Hopefully you'll get full marks. Okay, so the conventional energy sources, what are the advantages? The advantages of conventional energy sources are they are cheap. You need not require much money to get the conventional energy sources. But the thing is, disadvantage is they are not unlimited, and they will be causing the environment pollution, for example like coal and all. So what were the advantage and disadvantage? Non-conventional are freely available, but conventional are not freely, means they are cheap available. Freely, what I mean by freely is their quantity is more. Okay, that's what I mean freely, but they are costly. Here the quantity is less, but they are cheap. Okay, so those are the advantage and disadvantage. As well as you can go through this like for 2 to 3 minutes, you'll easily get to know what are the advantage and disadvantage. You can write that one. Okay, next we have the important question, very important question. Explain the energy sources from tar sands and oil shale. Okay, so what is tar sand? By the name itself you can understand there is a tar and there is sand on it. How is it relevant? Tar sand means, if I show you one diagram, you have to remember this diagram. Okay, like this only. Both for oil shale and tar sand, remember like this only. Just the difference is that in tar sand you have a stone, and in that some oil content is there. You have a stone, and in that what is there? Oil content is there, and you will be doing some process like these processes. Okay, these processes are going like you will be steaming it, and then you will be condensing, separating the things, and centrifugal forces, and those things you will be doing, and then you will be getting the actual oil. But in oil shale, what you will be doing, that will be the same thing here, but you will be crushing this one. What you will do, you will crush this one and you will get the oil from it. Okay, that's all. What is the difference between the oil shale and tar sands? Very important, draw this diagram, and if you can draw this rough diagram, just practice once or twice, you'll get a slight idea what you have to make. Because if you just see and go, it will be very hard for you. You will be thinking like you will know this one goes here and all, but when you sit there for exam, nothing will come in mind. Fine, so you got to practice it once. Next question, at a short note on solar constant, beam radiation and diffuse radiation. Let me tell you what are the key points in this. Solar constant is a constant defined 1353 W per meter square. What? 1353 per W per meter square. This is the constant defined for how much sun radiation is coming at a particular area. That's all. Fine. and beam radiation is the angle made between the beam flux. Okay, so this is the sun and there are two flux coming. How many flux are coming? Two flux are coming. Which are those flux? Beam and diffuse. Which are those flux? Beam and diffuse. If beam radiation comes and falls on the surface, the angle made between the beam radiation and the surface is called beam radiation, and the diffuse radiation angle is nothing but the diffuse radiation which comes and the angle between the surface and diffuse radiation. Okay, that's all what you have to write in this one. So few more concepts are given as well as the formulas, you can go through it. Discuss the India's production and reserves of commercial energy. Commercial energy means which is used in what? Industry. What is commercial energy? The energy which is used in industry. Okay, and what we have to discuss? The production and reserve. Two things we have to discuss for commercial energy. Which are those two things? Production and reserves. So what are the India's production and reserves, and how does India utilize the non-conventional energy sources? So you can find some things here, like key points I will tell you. What are the production and commercial reserves? Fossil fuels, then come to coal and lignite, hydropower, nuclear fission, minor sources like the sun, wind, tide energy. These are the sources which used for commercial purpose, and you need not go through these points, you can write by your own. Okay, like what you can write here is how much that is getting produced, and like approximately how much tons are getting produced, where is it getting exported. Just export. Okay, this is the first point, export and production. And what else you can write? Year. Just write some years, let it be true or not, just write it. And years production, how much it happened, export and all, how much it happened, just briefly mention it for all of this. How much these things happened for this one, how much these things happened for this one and all. Okay, so that's all what you will be writing in the commercial part. In non-commercial part, three things you have to remember. See, there is a jungle. Fine, there is a jungle. Okay, there is what? A jungle is there. In jungle you have fuel wood. This wood is used for fuel, therefore it is called fuel wood. And agricultural waste, here some animals were there and that waste is called as agricultural waste, as well as animal dung will be using. Three things will be using. What are those three things? Fuel wood, agricultural waste and what? Animal dung. Okay, so these three things are for non-commercial energy sources. Next one is write with a relevant diagram, define the following: declination, solar altitude, hour angle and zenith angle. Actually there are many terms, these were the most repeated ones, so I selected these four. Declination, what do you mean by declination? Declination, by the name you can understand that there is an angle from which, if this is the sun here and this is the earth. Okay, just understand it like a story, it's very simple. This is the center of earth, this is center of sun, and draw a line in between those. Okay, and this is what the equatorial plane. The equatorial plane, the angle made between the line and the equatorial plane is called what? Declination angle. Okay, and next is the solar altitude. What do you mean by solar altitude? The sun rays and the projection of sun rays on horizontal plane. This is the sun rays and this is the horizontal plane, the projection in between those. Actually all look same. Previous also I discussed beam radiation, diffuse radiation, declination, solar altitude, or like one light will come like this and this will be horizontal plane, the angle between that is that one. Like that only it is there, just slight change of words. Okay, so you can remember it easily. Hour angle, what is hour angle? The angle through which, see, if this is the earth here and this is the meridian and this is the sun. Okay, this is what? Earth, this is what? Meridian, this is what? Sun. So how much angle should the earth turn so that this line will be perpendicular to this line? That angle is called as hour angle. How much earth should turn for this line to be perpendicular with this one is called as hour angle. Zenith angle is nothing but the angle in between the sun rays at noon. Okay, sun rays at noon, this is the earth, sun rays at noon, how much is the angle in between this one and the actual apparent angle? Means, see, the light gets diffused, right, when it actually comes. So the actual light, it should have come here but it came here. So this angle is called as zenith angle. Okay. The next one is local solar time. Local solar time means you are determining the time by using the sun's rays and the angle formed in between. By using that, if you determine time, that is called local solar time. Surface azimuth angle. Surface azimuth angle is there is a surface here and the sun is present here. Okay, and whenever you draw a line between the sun rays and the surface, at that time some angle is formed, right? That angle is called as surface azimuth angle. Latitude, you all know what is latitude. The lines drawn in the earth like this, these are known as latitudes, right? That's only latitude. So if you want the exact definition and the key points that you can go through here, but what I told is just the key points, how you can remember those things. Fine. So some diagrams also there. So in the exam you got to draw the diagram as well. So don't worry much, just draw sun here, draw earth here and draw a line in between and make that angle and say that is that angle. Fine. Next we have what are the various instruments for use for the solar radiation. Explain pyranometer with a neat sketch. Also explain pyrheliometer. So for pyranometer and pyrheliometer, just remember like this: there is a building structure with a dome. There is a building structure with a dome, and the sun rays falls on this dome, and there is a black surface here. There is what here? Black surface. So in black surface, the it gets heated up and the EMF is generated. That is called as pyrometer. And pyrheliometer will be like a telescope. In the telescope, the light light will come, inner surface will be black, and because of the inner surface is black, the radiation gets reflected like this, and it will be producing some EMF. That is the main principle of pyrheliometer. So as you can see, this is a structure like dome. Sunlight comes from here, and the processing happens from here. Okay, and the rest are the supporting structures. Like that, you can draw the diagram and explain in your own words. What I told is the main ingredient of the answer. And this is like a telescope, pyrheliometer. That's all what I told. You can go through it. There you can find out the more information. Okay. Next we have the write a short note on spectral distribution of extraterrestrial radiation. See, here are two things which are concerned to us. What is a spectral distribution and what is extraterrestrial radiation? Extraterrestrial radiation means this is the earth's surface, and whatever is around the earth's surface, that is extraterrestrial. This is terrestrial, this is extraterrestrial. Okay. And spectral distribution means how is the light getting distributed in this surface is called as spectral distribution. So as the wavelength decreases, as the wavelength increases, the spectral radiation decreases. As the wavelength increases, what will happen? Spectral radiation will decrease. This is the diagram you have to make at the end, and the theory part what you have to write is the intensity of solar radiation away from the surface of the sun and through the near the surface of the earth remains changed because of two reasons. It changes in between. Why it changes is because the variation of radiation emitted by sun itself varies, and second, the earth is not constant distance, it is elliptic. What I mean is, if this is the sun here and this is the earth surrounding, here the distance is less, when the earth is here the distance is more, so the value will change, right? So that's why only you can see the variations here. So these are the three key points you have to mention. Rest all it's upon you. If you can go through it and mention in the paper. Okay. Next we have briefly discussed the solar energy options for supplying energy needs. How can you use solar energy to supply the energy needs? So that's what's the main question. You can use two ways: indirect or direct method. In direct method you have thermal and photovoltaic. Indirect method: water power, wind, biomass, ocean energy, marine current, wave energy, and ocean temperature difference. If you can remember these key points and explain each of these key points, it will be more than sufficient. Okay. So different types of energy and the energy applications also, they're like solar heating, cooling, pumping, greenhouse energy, and cooking. So you'll get many content. Fine. That was about the module 1. Let's move on to module 2. Describe in brief the different methods to store solar energy. So solar energy is here. How do you store the solar energy? To store the solar energy, you will be using what? Three things: thermal, electrical, or mechanical, or chemical. Let me give you a brief information. Thermal means what? Suppose that you have a ice here. To melt that ice, what you will do? You will supply some heat. Right, if you want to melt this one, you will be supplying some heat, it will become water. Now if you heat cool this water, at that time what will happen? Some heat will be released. That heat, how it got released? It was stored as latent heat when you had given this heat. When you had given this heat, there was a heat stored in the ice, and that became water, and that heat again we got it back. Like that only we will store the solar energy as well. When the solar energy comes, we will be storing it some cold surface that will be normalized, and when we want it, we will be cooling this one, so we will get the solar energy back. Electrical by using electrolysis, mechanical by some mechanical methods, chemical by some chemical methods. Okay, so more information can be found here, you can go through it. Okay, explain with solar ponds with neat sketch. What do you understand by solar ponds? Water pond means where you will be diving and doing swimming, right? That is what water pond. Solar pond means there will be solar parameters defined so that the solar energy is stored. Instead of water, what will be stored? Solar energy will be stored. But it's just like water only. There will be a pond here, there will be water also here, and there will be some stones here, and some chemicals will be here. What happens is, when the heat comes, that chemicals will absorb that heat, and it will be stored below the stones. So when we want solar energy, we will be putting some other chemicals, so the heat will be released. That's all what is there. You have to draw the diagram and you have to explain it in your own words. Okay. Next question is, explain briefly the factors affecting the performance of flat plate collector. What is flat plate collector? Flat plate collector is a flat plate which is a collector. Just as the name suggests, it is a flat plate which is a collector. So what it collects? It collects obviously solar energy. We are studying about solar energy, right? So it collects the solar energy, and what are the factors affecting it? Factors means by what factors the more solar energy will be collected, sometimes the less solar energy will be collected. That we will be discussing. Okay, so the main key points you need to mention is, the first one is the collection orientation. Collector orientation means, if here is the sun and if you reverse the flat plate collector and put it into the shadow, towards the shadow, will you get even one solar energy? No, you will not get anything. So the orientation matters. If you directly point it to sun, you will get the maximum energy. If you slightly point it to sun, slightly it will be reduced. If you will not point only, you will get nothing. Okay, that's what the first thing. Collector orientation. Here are some formulas to maximize the angle. How to find out which angle will produce more? That formula is present here. If you can by heart it, it will be helpful for you. Then the next is the selective surface. Selective surface means if you are using a glass, so I can give you an example here. If you are using a glass, or if you are using a rough surface in which you can slide and fall very easily. In glass you can slide and fall very easily, right? Because the surface matters. It is more smoother, it is more rough. Same thing goes for the solar energy as well. In some solar energy, if it is very smooth, it will capture a lot of solar energy. If it is not that smooth, it will not capture anything. Fine. So the parameters are defined here, by using which we can decide if it's a selective surface or it's not a selective surface. So how much ever terms you can remember from this one, you can remember. I told just the key points. Number of covers means the more number of covers you use, it might increase the solar radiation or decrease the solar radiation. That concepts are defined here. Okay. Fluid inlet temperature. There is a liquid traveling from the inside the flat plate collector. That liquid's temperature also matters. So it might be more, then the solar energy will be more. It might be less, then the solar energy will be more. That information is given here. Okay. Then we have effect of dust. So as much as dust is occupied on this one, that much it will block the sunlight. It will be very less solar energy. Okay, so these are the few things which you can define and explain to your own words. Get some key points here, like some formulas and all if you can. That will be helpful for you to fetch more marks. Okay, coming to the next one, which is explained with the help of usual expression, diffuse radiation, beam radiation, total radiation and reflected radiation on a tilted surface. Tilted surface, whenever you hear the word, what you have to first find out is, ask the person who is telling about it, what is the tilting angle? What is the tilting angle? Tilted surface means obviously there will be angle between this line and this line, right? This is the tilted surface. So this angle you have to first calculate. Based on this angle, the radiation's diffusion or the beam radiation will vary. So how much it varies, that will be calculated by what? That will be calculated by these formulas. Okay, these formulas you can use and you can calculate. There are numericals associated with that. So in the numerical part, I will be slightly giving a hint regarding what is this. So what is beam radiation? The ratio of the flux falling on the tilted surface, that to horizontal surface, is called tilt factor or beam radiation. As I told you before, sun is here, this beam radiation, and this is the surface. Whatever is the angle in between, that is called the beam radiation. If you calculate the ratio, it is called the ratio of beam radiation. Same goes for diffuse. If it is diffuse, it will be diffuse radiation. Total radiation can be calculated using this formula, and reflected radiation is the radiation which is reflected after having radiated. Fine. Next we have explained with a niche sketch the working of a liquid flat plate collector. Liquid flat plate collector. Okay, very important question. So make sure you go through it very well. So liquid flat plate collector, first make this diagram. I can give you a hint. Draw a cuboid like this, and here divide it into two parts. The top part will be the glass part, and here you will be having liquid. These are what? Liquid pipes. Okay, these are liquid pipes. It's not just circles. If you see it from this side here, it will be long pipes like this. Okay, that is what I am seeing from here. So what happens is the solar radiation will fall here, and the water will be going through it, and these are the sand particles, okay, insulation particles. So water will be going through it, as much means the sunlight will fall here. Obviously the water inside those pipes will be affected by the heat which is falling here, and the water will be becoming hot, right? So if the water becomes hot, you can use that hotness to store it somewhere, right? That's what the main concept behind the liquid flat plate collector. So that's why when you go to a bath, at that time the solar, if you have in your home, that the water will be hot, right? So that's based on liquid flat plate collector itself. Okay, so that's all what you have to mention here. You can go through it once. You can get more information regarding it. Explain the solar thermal power cycle. See, whenever they ask cycle, what you have to do is first draw a circle like this. Okay, because cycle will obviously rotate. It's a cycle, right? So after that you have to fill the information. First you will draw a circle, then you will fill the information. And what are the key points is that you have to remember. So what are the key points in thermal power cycle? In thermal power cycle, first the heat will come, that will go to some processing. I am explaining very briefly. Okay, very top. You have to obviously go through it once. If you draw like this, you will get 0 marks. Okay, this is just for your remembrance. Okay, so what happens is the heat will come here, some processing will happen, and that processing part will be stored here, and after that gets done, some chemical processing will happen, and after that is then the condensing will happen, and condensing will again come here and it will be evaporated. Then this cycle repeats. Okay, that's the very top overview. Remember these 4 steps, and detailed information can be found here. Okay, so you can also add extra information like low temperature thermal power cycle are the medium temperature, high temperature. These vary between 100 and what 400 degrees Celsius. One key point you got. And they are different, they use the different instruments and they are located at different positions. They use what different instruments and they are where they are located at different positions. Okay, so flat plate collector or solar ponds are used for collecting solar energy. Medium temperature use line focusing parabolic collector. High temperature use parabolic dish collector, okay, at the top of the towers. Okay, so here some information is there, what temperature it works at and what happens first and last, and this is the main diagram which you have to make. Okay, here what happens, see, the solar radiation is happening here, water is coming from here, it will be evaporated and some things will happen in the storage tank, it will be stored, another processing will happen, it will get pumped here and it will be condensed, again the cycle will repeat. Fine, that's all what is there. Draw this diagram once, it will be helpful for you. Then the next one is explain the transmissivity based on reflection refraction in relation to flat plate solar collector covers. Very important derivation from exam point of view. Okay, so this equation you have to derive. First make this diagram here. In this diagram what happens, there is a light coming from here. Suppose that there is sun here and the light is coming from here, it gets refracted here. It should actually go like this, but because of this cover it gets refracted. So there is a difference in angle. This is theta 1, this is theta 2, and this is the refracted beam. Next you have to write sin theta 1 by sin theta 2 is equal to n2 by n1. n2 is the refractive indexes of the this medium and this medium. Okay, now what you have to do, you have to write P is equal to half P1 plus P2. What is P1 plus P2? Those are the two components of polarization. Remember this formula about the tan and the sine, and then you can find out the average. After that you have to give the transmissivity equation in this form. Just 5 steps, very simple, you can easily get 10 marks. Okay, and this is for the multi cover that I explained for the single cover. Here also the same thing, just multiple covers will be getting considered at each level. So this is the formula which you have to write. Okay, so the derivation is not there here, just the formula is given. Okay, write a short note on solar collector performance. Solar collector, how the performance gets affected. Okay, solar collector, there are two types, non-conventional or flat plate or concentrating. So by the name itself you can understand there are two types of what solar collector. See, performance means what output you are getting, something you are giving in and you are doing something and some output you are getting. The performance depends on what is happening here. So let me tell you, two things are happening here. How many things are happening? Two things are happening. Two things are non-focus, just remember like this, non-focus and focus. So in non-focus what happens, it's a white surface, and in focus it is just a small surface. Okay, so whenever the heat means falls here, it will be covering a wide area and each of these points will be having less intensity. But here what will happen, whenever the heat is coming, all the heat will be focused on this same point. So high intensity temperature will be produced here. Right, so that's what for the different applications, sometimes you need this one, sometimes you need this one. You know, right, when you get a magnifying glass and put a paper in that, and when you focus all the heat which is present at this same point, you will get means the paper will be burnt here. That is what the focusing type is. Non-focusing type is a wide area, you will be getting the area in a very large surface, and but the temperature will be not that much high as much as focusing one. So that's what is mentioned here. You can go through it for more information. Okay, what is the principle of conversion? You will be using the greenhouse effect. So in greenhouse, let me tell you what happens. So greenhouse is here and the sunlight is coming from here. Fine, when sunlight comes here in the greenhouse, the heat gets trapped. Okay, because where greenhouse are made in places where there is more cold temperature. For the trees growth, it requires hot temperature. In the outside area it can't grow because it is very cold. So what we will do is we will make a greenhouse. In greenhouse what happens, sunlight will be trapped here. When sunlight is trapped here and there is a difference between the outer surface and inner surface, the carbon dioxide wavelength will be affected. Because of this effect, the other temperature will also be increased. So that is known as global warming. By using this phenomena only, we will be making use of solar energy. Okay, by using this phenomena only, we will be using the conversion to thermal energy using collector. Okay, so go through it once, you will get the solid idea what it is. Then we have to explain the different types of concentrating collectors. Explain anyone with a neat diagram. So what are the concentrating collectors? First we have to explain that. Then which is your favorite? Choose that and explain. So I'll tell you a few ones, very simple ones. So there are two types as I told, concentrating and non-focusing. Right, concentrating are these types and the non-focusing are these types. So few are here, just you have to remember the diagram, very simple, just remember the diagram. It's like a glass shape here, the reflection comes here and the EMF is generated here. It is like a black surface here, and heat comes, and inside the black surface the heat will be trapped. It's like a dish one, here the heat surface will come and this will be trapped. The same thing you have to explain here, how high it is, what is the radius. Okay, those things you can mention in your own words, what is the diameter and all. Okay, basically you have to remember these three diagrams, very important. Okay, next one, explain the heat transfer process in LFPC with a neat diagram, and also explain the balance equation and explain each term in it. Three things we have to do. Explain the heat transfer process. What is the heat transfer means? There is a point A, there is a point B. If the heat is transferred, that is called as heat transfer. In LFPC is liquid flat plate collector, very simple. And write the balance equation. So what is the balance equation? How much energy is present here, that much only will be present here also. If there is no heat loss, that equation we have to derive, and what are the terms we use to derive the equation, that we have to explain. So let's first understand the working principle of it. So this is the diagram which you have to make. The first point, second point, energy is transferred from input to output. This is the pipe in which energy is getting transferred. Okay, so the same thing, it's very simple. To calculate how much is the energy loss, the heat loss from the collector can be calculated using the average temperature known. If you give me the average temperature right now, I will give you how much is the heat loss, but the thing is we don't know what is average temperature. To derive the average temperature, what we have to assume is how much heat is coming here, that much heat only will be present here. By using that, we can easily derive the average temperature. Now give me the average temperature, I will give you the heat loss value. How is the balance equation is, how much heat is given, that much heat will be the output. That is the balance equation. Here some derivation part is there. If you can practice this and go. It will be if this question comes, it will be helpful for you. Okay, the balance equation you have to write this one. QU is equal to APS minus QT, which is nothing but useful energy is equal to absorbed energy plus thermal losses. How much you absorbed and how much it's lost, add that. That's what the input you are given with, right? That's what it's mentioned here. Some few points are there, you can go through it. And the efficiency, if they ask about, they have explicitly asked the efficiency as well. Efficiency is means how much was given to you, how much you made use of it. So how much is the useful heat divided by how much was incident on the collector. That is what the efficiency is. Okay, so here are some terms, you can go through it. The meaning is also written here. Explain the working. So coming to module 3, 4 and 5, this why I took as 3, 4 and 5 together is because they are related with each other. Many questions overlap in these 3 modules, so I took it as each other. There are totally how many questions? 9 questions. In all these 3 modules together, 9 questions are there, very important ones. Explain the working principle of photovoltaic energy conversion. What do you mean by photovoltaic? Photosynthesis, right? So that's what is mentioned here. In photovoltaic, you will be using, instead of photosynthesis, solar cells. Okay, so if the sunlight comes, how can you make use of the sunlight to produce electricity? That's what the solar photovoltaic conversion means. So this is the diagram which you have to make. Let me tell you what are the key points you have to write. First, make a cuboid like this. What you will make? A cuboid like this. Then draw this structure here, as you can see, like a fork structure, right? Draw that fork structure and make some lines like this. And here you will be coloring very dark. At the bottom you will be coloring very dark. So these are the 4 things which you have to keep in mind. And after that, what happens? Here the sunlight comes, and here some p-n junction processing will happen. The electrons in the holes will be exchanged with each other, and based on the exchange there will be an extra energy generated that will be collected and turned into voltage. What will happen? Sunlight will come here, and that will be passing through the insulated part here, and then it will be going through p-n junction. When the energy or the light comes and passes through the p-n junction, the transfer between the electron holes and the electrons. See, positive means holes and the negative means electrons. These two will be exchanged. When these exchange, there is a slight energy released. That energy is collected here, and when it becomes very big energy, it will be converted to EMF. That's the same thing here. Just say what is the dimensions of it, and what is this one, what is this one, what is the working principle, like what will happen, the electrons will get exchanged, how it is getting converted, and those things are present here. You can go through it, fine. And application also there, solar farm, remote location, and power in space, building material needs, building related materials, transportation, and so on. Next we are explaining the neat diagram, the horizontal axis windmill. What do you understand by the term horizontal? Horizontal means like this, right? This is horizontal, okay? That much only you have to remember. Horizontal axis windmill. Windmill, draw a windmill like how you used to draw when you were a child. Draw like this. Draw like this. That much only. How you can draw it, okay? But make sure that this is horizontal. This should be like this, okay? Then what you have to mention is what is the working principle of it. So working principle is very simple. we already know what is working principle. The wind will come from here, because of that this will get rotated, and if it's rotated there will be a movement produced. Because of that movement EMF will be generated by the that formulas we studied in the 10th standard, right? How the generator formulas, if there is a movement here in the flux, there will be EMF generated, right? So that's what the same principle here inside the motor, that only will happen. There are 3 types, you can write this one: Dutch windmill, multi-blade windmill, high speed propeller type. If you want, I can explain this also. Dutch windmill will be having a slightly different variation, that I'll show you the diagram. Multi-blade will have multi-blades, high speed will be having high speed. Fine. So this is the diagram which I have to make. Same thing what I told you. Draw, this is the rotor, which is the, like this we used to draw in the childhood. This is mentioned here from a different angle, and here the things are there, driver, controller and all, and here the foundation is there, here the power will be there, and the electrical system will be generating this one. So when this rotates, the driver will be having that 10th standard thing, generator equation. Based on that the EMF will be generated and that will be stored here. That's what the horizontal axis is. Construction details, how high it is, what is the radius, that you better know than me, right? You can write me onwards. And working principles, just as I told you, that's the same thing here. Based on the speed you set, the more energy will be generated. The gears will be different. High speed shaft will be connected to the generator, which converts the rotational motion to AC voltage. The main ingredient, the leg piece of this whole answer is this one: rotational motion will be converted to AC voltage. If you miss this one, you will use 90% of the marks. Fine. Advantage, disadvantage, you can write by your own words. Moving on, we have the explain the advantages and disadvantages of OTEC, tidal energy and geothermal. See, let me tell you, don't memorize the advantage and disadvantage of each individual of these. Just keep in mind what are the basic advantage and disadvantages. The disadvantage will be more costly, it will be affecting the environment, many people will be getting affected by it, and sometimes the setup part will be very it will be required very security or the safety purpose, or it will be destroyed very easily. Those are the disadvantages. Advantages is it is freely available, it is renewable, it is environmental friendly, you can carry it anywhere, you can get the energy means regardless of the temperature of the surroundings, and the area does not matter, anywhere you go you can get the energy. So those are the advantages. So if you are there, if you spend 10 minutes and go through it, you will get a brief idea what to write. Okay, so don't write exactly same for all the three, just by the name you can alter it. Okay, what I mean is OTEC is what? Ocean thermal energy conversion. Tidal energy by using tide. Geothermal by using geothermal. So there you can get few points, like what is geo means the earth, thermal means the energy or the heat present inside the earth, how it comes out. Based on that, what is the thing which you present here, and by using that thing, if the heat comes, the electricity will be produced. Something you can write like that, make a diagram and make a instrument which can be used in that situation. That based on your creativity you can do whatever you want. Okay, moving on to the next one, we have the important question, which is the tidal basin, double and single basin. Tidal power plant under double basin and single basin. All you have to remember is this diagram. This is the single basin diagram. It is from a up. Okay, means what means, if you have played GTA San Andreas, in that if you type Rocketman, you will be getting a jetpack, right? In that you will be going up, right? So like that only, you got a jetpack and you have gone up, you are at mountain level, and from top of the earth you are seeing this. Okay, so here is the ocean part, and the ocean is coming from here. Here is a empty valley, you know, right? It's a empty space in the dig in the earth. So there what happens is the water will come here, and based on the speed of water, some things will be present here that will be shaken. When these things are shaken, that will be producing a rotational motion and the energy will be produced. So, and it will go back like this. Okay, so that's what the tidal plant is. This is single, that's why it is single basin. If it is double, it will be called double basin. Okay, let me show you double basin. This is double basin. There will be two things, it will come from here, it will pass through this turbine, again it will go back here. Okay, very simple. And if you want to draw these things from a different angle, you can draw it like this, like you are in the ground and you are seeing it from here, the sea is here and this is the building here and this is the valley. It will come like this, it will go like this, it will come like this, it will go like this. That's how tide is, right? Tide will come fast like this, it will go like this, right? That's what the things are present here, by using which you can harness the energy. Okay, so few more cue points are given here, you can go through it for your more information. Next is the explain briefly the factors affecting the biogas generation. Very important. What are the factors affecting the biogas generation? How it is produced in Indian type biogas plant? What are the applications? Very much repeated question. So what are the factors affecting the biogas generation? Few factors are given here, and the explanation regarding that is also given. Actually, explanation is not that much required also. pH value, we all know what is pH value, more acidic or more basic. Temperature also affects. Total solid content, how much the dung you provide, what is the load rating, how much load you provide at the particular moment of time, seeding, uniform feeding, what is the depth of it, carbon to nitrogen ratio, nutrient mixing, retention time. But still, if you want the diagrams for each of these or the more information, that also I have included here. For each of these you can go through it, fine. And Indian KVIC floating drum. Okay, so here is the biogas plant. So the thing what you have to remember is, first you have to draw this diagram, explain the construction part of it, explain what are the components present here. After you have done this much, then only move on to what? Working principle. After you do what, you have to move on to working principle, draw this diagram, explain the components used in it, and what is the constructional diameters, like how much length and the diameter is it, and what is present here. After that, explain what is the working principle. Start from here, it comes here, then it goes like this, again it goes here. In 5 seconds I will tell you what happens. Dung and water will come from here, the gas will be produced because of chemical reactions, gas will be coming here, and that will be the output which is getting here. Here we will be using the gas, okay, sorry, here we will be using the gas, here the other output will be there. That's all what is mentioned. Go through it once, the concept will become solid in your mind. Okay, advantage is also there, I need not explain this one, you can go through it. And applications of biogas also there, like for the diesel, for the alternate diesel engine, diesel fuel engine, or the alternative fuels, right? Mainly for fuels there are different words they have used, just that, and slight at very technical terms there are changes here, like what are the applications of it, but mainly for different types of fuels and the different types you can use this one. You can go through it to get the actual changes which is mentioned here. Okay, next one is, yeah, this is also super important one, which is different methods to produce hydrogen, storage and transportation of hydrogen, application of hydrogen. How do you produce hydrogen? From the childhood we learned the production of hydrogen is by electrolysis. So here's the key concept: electrolysis, current will be passed, some chemicals will be there here, and the last you will get what? Hydrogen. That is what electrolysis. If you use it in an industry, you will use many electrolysis, that is tank type electrolyzer. And filter pass, there will be a filter in which you will be passing the electricity to get the hydrogen. Thermochemical methods will be using the chemical methods as well as the efficiency of thermo plants to get the hydrogen. And here are some instruments given here, like Westinghouse, ISPA-Mark, and iodine sulfur cycle. By using fossil fuels also you can generate by heating the fossil fuels and doing some specific reactions. Solar energy by using the bio or photo. Bio solar energy means you will be using the plants, and photoelectrolysis means you will be using the photovoltaic effect. Okay. Hydrogen storage, how do you store the hydrogen? Compressed gas, either compress the gas and store, or compress it more and make it liquid, or line pack system, there will be packs in which the line of pack will be there, each hydrogen will be stored, like that also you can store, or dig it very underground and store there, or store it in metal hydrides, a very strong metal. Inside that metal what will be there? Obviously hydrogen is there, that's what we are talking about, right? Next one what you have to focus is hydrogen transportation. You can transport it using pipelines. Pipelines means there will be pipe here and pipe, and this is like a line, that's why it is called pipeline. Hydrogen can be transported here, but the disadvantage is that the hydrogen will get expanded and it will be reducing its value. It will be not like this big one, okay, it will be very small, okay, like this it will be, but still the hydrogen will be getting affected by it, fine. So liquid hydrogen transportation, make it into a liquid and transport, or put it in the metal and transport. Okay, so if you go through it slightly once, it's very easy, you can get the key points. Just what I'm telling is what you have to remember. Okay, at least if you sit in exam, one word you should get right, that one word I am telling. After that you have to go through the concepts and get the more information. Okay, that's your duty. Applications for residential, industrial, alternative fuel, power generation, and for motor vehicles you can use hydrogen gas. Okay, discuss the factors for wind turbine selection. So see here, we cannot make wind turbine wherever we want, like in our home if we make, it will not be that better if you make it any if you make that in top of a mountain, their wind will be very high, you will get a lot of electricity for free, right? So what are the different factors? One factor I told you, what are the different factors that you have to keep in mind? So let me tell you what are the few factors. So high annual average wind speed is there, availability of some data, wind Y how much is there, wind structure, altitude, terrain means location, which location you are going, and what is the aerodynamic factors present in that location, local ecology, distance, nearness, and the nature of the ground, favorable land cost, where you make the cost will be lower to make, where there is more wind in the whole year, and what is the environmental condition of the people living in that area, whether they will be affected by this construction of this building or not. Those all are the different factors which you have to keep in mind. Next is explain with the need diagram the closed OTEC and Rankine system with advantage and disadvantage. OTEC is the ocean thermal energy conversion. So closed and open, there are two types are there, closed and open. By the name itself you can understand one is closed, other is open. Few key points are there, you can go through it. Okay. And this is a diagram which you have to make. Here also it is a cycle, so first you will draw like this. What will happen here also, same thing is happening. Liquid ammonia will come, it will evaporate, and it will, the vapor will be there, again it will get condensed, again it will happen. In between you will get the energy. Fine. Then we have the Rankine cycle. Here also the same thing, something will get evaporated, something will get what, condensed. Next, explain with a neat sketch constructional details of a KVIC biogas plant. See, what I am telling you is the Indian biogas plant I told you, right? That one was explicitly asked 5 times. This one was also explicitly asked more than 5 times. But the answer is same. Both are same. So 10 times it's repeated. Make sure you practice the diagram. Spend more time for this one than the other questions. Very, very important question. Same answer, just in a different words they have asked. Fine. Then this is the last question. Explain the harnessing of the tidal energy, photosynthesis, energy plantation, anaerobic digestion. Need not look the definition also. How do you harness the tidal energy? For electricity purpose. Photosynthesis. What is photosynthesis? Conversion of the sunlight into the food made by the plants is called photosynthesis. Energy plantation, you will be planting some plants just for the fuel purpose. Okay, means when the plants grow, you will cut those plants and you will be using it for fuel purpose. That is called energy plantation. Anaerobic digestion means the chemical reaction happening or the process happening in the absence of oxygen is called anaerobic digestion. That happens in biogas plants. Okay. So yeah, some more information is given here. You can go through it and the formulas and all diagrams. Fine. So basically that's it about the theory part, and if you are done with the theory part, then only move on to the next part of the video, because numerical part is a bit complicated one, and it carries around 30 marks. So even if you skip it, it's fine. Anyways, I'll give you a brief overview of what are the types of numericals asked. Okay. So let's move on to the numerical formulas. So these are the formulas. Okay. Solar radiation. This one formula, there is a formula for solar time, and I'll discuss in depth in these things. First, let me give you a brief overview of how many types of numericals are there. Solar radiation is one of the type, and in solar radiation only there are many types. Okay, for calculating the different values. And here is the glass covers, different types of transmissivity. Okay, here's this formula, and the next one. So the next ones are the flat plate collectors. In the flat plate collectors also many parameters are there, and those I will be considering during the application part of the numericals. And the next one is the wind energy. In the wind energy also there are few parameters, like you have to calculate the speed of the rotor, the energy generated, the power or the voltage generated, or the speed of the rotor. Those things are there, kinetic energy and all. So these are the formulas. So other wind parameters also some formulas are there. So yeah, that's all what is there in the formula part. These are the like 7 to 8 types of numericals. So from each numerical I will be discussing few examples, and I will be telling you how to memorize the formulas and those things. Okay. So local solar time and declination. Okay. So I suggest you to open this PDF in a separate device, so that when I refer to the formula, you have to go back and refer to the formula where I am telling. Okay. So it's better if you open this in a new device. I'll be also opening in a new device, and from there I'll be referring. Okay, the formula part, and I'll be just explaining what is substituted here. Okay. So the first type of numerical can be local solar time and declination. Very simple. You have to calculate what local solar time and what is the declination angle. So the question is, determine the local solar time and declination at a location of latitude 2315 and longitude 7730 at 1230 IST on June 19. Equation of the time correction is given from the standard table or the chart. So this is the equation of the time correction given. So what you have to calculate, the local solar time. So the formula for local solar time, if you go to page number 96, there I have mentioned the solar time is equal to standard time plus or minus 4 LST minus LLOC plus E. Okay, that's the formula which we'll be using. So if you use that formula here, IST which is given to us is 1230. So you'll write it as 12 hour 30 minutes minus 4 into 8230 minus 7730. 8230 is what? 8230 is given here. Okay, so that is the standard time longitude of India, that is 8230. So that you have to memorize, I guess. So 8230 will be written here minus longitude 7730. If you subtract this, what the answer you get? 82 minus 77 is 5. So you'll be writing here 5, and 4 is from here, and 1230 it will be here. Minus 101, that is given here, that is the equation. Okay, so equation of time correction, that is present here. So when you calculate this answer, what answer you get? See, 12 hour 30 minutes minus 20 minutes minus 1 minute 1 second. So if you calculate that, you will get this answer here, 12 hour 8 minute and 54 seconds. Next, they have asked also the declination. For declination, you have to use the Cooper's formula. So Cooper's formula can be found in page number 96. So page number 96, the second formula, the page number 96 second formula, you can find the Cooper's equation. You have to substitute this one. This is the standard value 23.5 sine 360 by 365 284 plus n. N is what day we are calculating with respect to year. So June 19, I guess June 19, yeah, June 19 is what day? June 19 is what day? It is the 178th day. Okay, that you have to calculate and substitute. Easily you get the answer 23.43. Moving on, here we have the next one, the same thing, local apparent time you have to calculate, time is given and the date is also given and the equation time is also given. Same formula, IST minus standard local time minus longitude location plus equation of time correction. This is given 12 o'clock, so I took 12 o'clock, 4 into what is the standard time, 8230 minus 8144, which is given to us in the question, minus the correction time. When you calculate, you will get the answer. The first step of numerical, local solar time and declination. Then we have daylight hours. How do you calculate daylight hours? Calculate the day, number of daylight hours. Daylight hours means how many hours the day was, how many hours the day was. Sunshine hours in Srinagar on January 1 and on July 1. The latitude of Srinagar is 34 degree 05 north. Okay, so from the data which is given to us, n is equal to 1 January 1 and n is equal to 182 for July 1. That is the number of day of the year. January 1 is the first day, July 1 is the 182th day. Okay, so for January 1, July 1, after you get that, calculate the declination. Very simple. After you get the declination by Cooper's equation, then for two answers you get for January 1 and July 1, and then what you have to do is you have to take this formula. So this formula you will get in the page number 98, the 10th formula, daylight or daylight hours. Okay, so for September 22, March 21, 1 is given, March 21 to September 22, 1 is given. Mostly they'll ask between September to March only. Okay, so don't worry about that. So anyways, the formula is given here, it's not much difference. How do you remember is 2 by 15 into cos inverse of minus tan 34.083 and tan what declination angle you got. 34.083 is the standard value, I guess. 34.083 is the standard value which will be using for the latitude of Srinagar. The latitude of Srinagar, that angle divided by what angle declination you got, calculate the minus tan value of it and multiply by cos inverse of 2 by 15. Same goes for this one as well. So you get two answers, very simple. Okay, and another question here, see here what the latitude is given, this is the latitude. So always you have to consider what the latitude. Okay, so so latitude is 22 degree, so 22 degree will be using here. After calculating the declination, after calculating n, you will get the declination value. Use the declination value here and latitude value here given in the question, calculate this one, you will get the daylight hours. Next we have the beam angle. Okay, beam angle, calculate the angle made by the beam radiation. There is a beam radiation and calculate the angle made by it with normal to the flat plate collector on December 1. There is a flat plate collector and normal to the flat plate collector means this one. What is this angle? Okay, in between this, what is the angle at December 1 at 9 a.m. 9 o'clock at December 1 you have to calculate, and the solar time is given to us is 28 degree 35. Collector is tilted at an angle of latitude plus 10 degrees. So what is the collector altitude? With the horizontal and pointing towards the south. So since it's pointing toward the south, gamma value will be equal to 0. So what is the equation we will be considering is this equation. Okay, this equation where you will get is, so if the gamma value is given as 0, we will be using this equation. In this equation we will have to calculate the theta t values. Okay, so the equation slight variation is given in page number 97, you can find out that one, but this is the formula we will be using here, and in the question where gamma is equal to 0. Okay, so remember what all you have to substitute, the phi value, s value and the gamma value and the w value. Okay, so declination first we will be calculating by using Cooper's equation. Easily you will get this answer. Then R angle corresponding to 9R is 45 degree. Okay, remember for 9R it is 45 degree. So when I substitute these ones, what is 28.5? 28.5 we got from here, that is given in the question, 28.35. So 28.35 minutes. Okay, 35 minutes is equivalent to 58 degree. Okay, so the calculation you can get from the Google itself, what is the calculation from minute to degrees. There you can get to know how to calculate from minute to degree. And 38.58 is nothing but sunlight radiation value, which is 38.58 for the given latitude. So when you substitute these values here and calculate the answer, you will get the cos theta t value, or the theta t value will be equal to this one. Okay, So that's what you'll be doing in this equation. They have just asked the theta t value, right? What is the angle made by the beam radiation with the normal flat plate collector? Okay, so this question is also there in textbook, and go through it. The similar question is here, the calculate the angle made with the beam radiation. So here what are the things given? Here also the gamma value is equal to 0 because it's pointing to south. Whenever you see the term pointing to south, you have to take the gamma value as 0. Okay, in cos theta t, the same equation, remember this equation, in most of the question this same equation is used, and declination can be calculated using the Cooper's equation, and this one will be corresponding to this one. How do you calculate is 45 degree for 9 hours, and this one will be just substituting. 36 is given here. Why it is 36 is because the angle in which it is horizontal. Okay, see what I mean is the collector at an angle of 36 degree with the horizontal. How much the angle between collector and horizontal, that you have to take here. In the previous question, how we got this one is 38.58 is, it is given in the question that it is tilted with an angle of latitude plus 10. Latitude plus 10 means latitude is 28.35 plus 10 means 38.35, and 38.35 is equivalent to 38.58 degree. So that's what I have written here, 38.58 degree in this equation here. That's why the answer was 10, and here the answer is minus 36. Okay, with 36 is explicitly given to us. Calculate the theta t value, easily you will get the beam angle radiation value. Okay. Next one is the monthly average. In monthly average, the dates on which H0 is equivalent to the mean value. When the H0 is equivalent to mean value, those dates are this one. So basically, they might ask the question with respect to these dates only. Even if they don't give, just they say like, for example, October, you have to consider October 15, because at that time H0 equal to the mean value, you will get the answer easily. Okay. So how do you calculate the monthly average hourly radiation falling on a flat plate collector facing south with a slope of 15 degree? Here gamma is 0 and slope is 15 degree, and the data is given to us in this way. Okay. So what equation will be using, that can be found in the page number. So the answer can be found on the page number 98. I mean the formula can be found in the page number 98. Monthly average global hourly radiation, that's what they have asked, right? Monthly average global hourly radiation. There you can see many terms like the IT, IG, and the ID, RB, and RD, as well as RR. So let's see what are those terms means. Okay. So for each of these, there is a formula given to us. Okay, for calculating RB, RD, and RR, when you get these three terms, they have given the value of IG and ID. Just substitute these 5 terms, you will get easily the value of IT. Okay, so how do you calculate these terms which is present here? The gamma value they have you have to calculate using the Cooper's equation. Phi and beta, how you will get the value of phi and beta? Okay, here by using this one you will get the value delta value, and since Chennai is given as 13, the phi value will be 13, and beta is the slope, so it is 15. So and W is taken as solar time minus 12 o'clock in hours into 15. Solar time which they have given minus 12 o'clock into 15, if you do, you will get as 0, because the time is also 12 o'clock. 0 into something is 0 only. RB value, just substitute these three values in this equation, you will get RB. RD also will calculate in the same way. RR also will calculate in the same way. Then IG and ID value is given, substitute here, easily you will get the value of IT. Again another question here. Here also gamma is 0, slope is 10, and local orientation. Now you are getting the idea, right? What all you have to consider while calculating this one. Time is given to, that is nothing but solar time, and assume the ground reflectivity to be 0.23. Here ground reflectivity is also given to us. So declination angle you can calculate same as the previous question, because the location is same, and here the phi and beta value is given to us, and the W value will be getting, RB also will be getting here, RD is will get, and RR also will get. So when you substitute the value of IG and ID in the equation, you will get the value of IT. Okay, so this is the value of IT which you will be getting. Let's move on to the next one. We have the glass type of questions. In glass type of question, the formulas you can find from the page number 99. If you go through it once, you will get to know what are the terms used and what are the formulas you have to know. Anyways, you have to memorize this one, because for the derivation it is asked most repeated questions. So you'll be going through it, right? You'll be remembering the formulas as well. So one of the type of the question is plot the variation of tau R, tau A, and tau with the angle of incidence from the following cover system. Okay, so some parameters will be given to us. Let's see how to solve this question. When they ask what is the variation of even if they ask to calculate tau R, tau A, or tau, how we have to calculate? First, see what is the angle given to us. So the angle given to us is 15 degree. Okay, so even if they have not given the angle, consider it as 15 degree and start. So theta 1 is 15 degree, theta 2 will be calculated by using this formula. This equation you can find out in the page number 99. At the last line they have given a formula, sin theta 1 by sin theta 2 is equal to n2 by n1. By using that you will get the theta 2 value, and P1 and P2 value also you can find in the corresponding pages, like in the page number 100 there you can find P1 and P2 values. Substitute the theta 1 theta 2 values, you will get this one, and to calculate the tau r and tau r1 tau r2, those values also given in the corresponding pages, which is in see those values you can find in the page number 101. Okay, in the bottom you can find out the values, how to calculate these values. That this substitution part is there, you will easily get the value of tau r and tau a. Multiply these both to get the value of tau. Okay, once you write in practice and go through the pages which I told you, you will easily get to know what to do. Okay, then we have the glass cover system. How to do this one? Same type of question present here. Theta 1 45 is given, so we will take 45. Where is 45 given? 45 is given here. Okay, then theta 2 you will calculate P1 P2 tau r1 tau r2, calculate tau r and calculate the tau p value. Here only tau p is asked, so tau p will be calculated in the following way. Okay, 2 glass covers it's given here, and theta 1 is this one, theta 1 for the case 2 is this one, k is also given, absorptance 0.94 it's given. What you have to find for both cases, you have to find Tp, T and absorptance transmittance product. For this one you will be using this formula. Okay, this formula you can find in the page number the formula which I was talking about. This can be not sure in which page, but this is the formula I had got in one textbook. So this is the formula we will be using, and PD value will be considering for 0.16 for one cover, 0.24 for two cover, 0.29 for three cover. And when you use this formula, you will have to just substitute. So for substituting, what you have to do is you have to find out tau alpha is given to us, PD you have to calculate, and the number of covers is also given to us. See here, if you read this question, the number of covers given to us is 2 glass covers. Okay, so which value will substitute here? The value which is for 2 covers 0.24. Okay, so all we have to calculate is tau value. How you will calculate tau value? Theta 1 is given, theta 2 you will calculate, P1 P2 tau r1 tau r2 and tau p you will be getting, tau a you will be getting, multiply to get tau, and by substituting the tau value here you will easily get the answer. For case 2 also you will be doing the same thing. Next type of numerical is the plate numerical. Here we have to determine the collector overall loss coefficient using the Kleen's empirical relation. So by using Kleen's empirical relation, this for the 45 degree slope ut is given to us, this is the ut value. Okay, and the terms which I mentioned here you have to by heart like this only, or they might give the formula as well, so you not worry much about the remembering this formula. Anyways, if you can go through it once, you will easily get to see some patterns. HW is given here, that value is substituted here, and F is given to us. So we need these terms for the substitution part. HW 5.7 plus 3 into 5, that one answer you will get. Substitute this answer in this equation, you will get F, and after that you will be using those answers which F and HW in this equation. After you substitute those values, and these values are given to us. Okay, so these values are given to us in the equation. So I mean in the parameter list. Okay, so for the particular question, some values you have to memorize, like 338 and present here, and 344. See, 344 is already given here. Okay, 344 you will be taking from here. So you just substitute those values and get the final answer. And for slope 23 you have to use the ratio u23 by u45. u45 already got, u23 just cross multiply by this one, you will get the final answer here. Okay, and this is another type of question where the data ranges, data for the flat plate collector, transmissivity absorptivity product, and transmissivity absorptivity product for diffuse radiation, for beam and for diffuse. The value is given to us. What are we supposed to calculate? We are supposed to calculate the total solar flux incident on the collector. Total solar flux you have to calculate, incident flow absorbed, and the instantaneous efficiency. Okay, so total solar flux is the equation is given this one. These values are given to us. If you go through the list, for example, ID, where is given ID? If you ask me, I'll tell you the ID is given here, I mentioned here. Okay, just in the question they will be given, you have to just substitute these values and find out the answer. Same goes for this one also, you just have to memorize the formula. And instantaneous efficiency, these are the terms are expanded here, those things are written, you can easily do it. Okay, data for the flat plate collector used for heating the building are given. So another type of question, here we will be using this formula RB. Just the angles are also given to us, easily you can do it. What are the angles mentioned here? Like for example, it's written 22 minus 37. How you got 37? 37 is what? The angle with the tilted value, right? Angle with the tilted value is 37 degree. Now if you ask me how it is 37 degree, so what I will tell you is the angle of tilt is how much it is given, 15 degree plus latitude. Now you'll ask me what is latitude. I'll tell you the latitude value is given here as 22. So 22 plus 15 is what? Obviously it is 37 only. So I have written here 37. Like that only you will substitute for all. If you have time, go through it. You'll get to know exactly what are the substitution made. It's actually very time consuming to actually explain each of these terms. Very simple. You can go through it by your own. You'll get to know. And then we are calculating the same thing. Tau into alpha 1 minus alpha into PD number of covers it is given. Based on that you have to substitute that value. Already I have mentioned that. Here some formulas are there for H0 and S values. So just go through it once. If you can get to know the concepts, then it's fine. Else you can skip this one. Okay. Then what we have is the wind type of questions. So in wind type of question, they might ask you total power, maximum obtained power density, reasonably obtained power density, total power, torque and axial thrust. So turbine diameter will be given, speed will be given to us. All you have to do is pay attention to the formula. Total power formula is this one. Density into A into V1 cube by 2. Substitute those values, you'll get the answer here. Maximum power density, one formula, P max by A. What is P max? P max is this one, 8 by 27 into this term here. That will get P max. So this term is already calculated. So you means use the same term here, and you'll get the answer for this one, like 1.226 you already got from here. Substitute that one here, and you'll get the maximum power density. In the same way, efficiency is total minus total divided by the area. Total power by area, P by A. Total power is equal to power density into area. Torque at maximum efficiency. Some formulas are there. All the terms are given. Just remember the formula and substitute that. Okay. So problems on wind energy here also they are given. You can go to this one. Same whatever I mentioned here. COP of the rotor and all. So some terms will be given like U0, U1 and tau A and all. So when you read this one, for example, I'll tell you for one of the question. They have asked you to calculate total power available in the wind P0. If you know the formula of P0, half the density into A into U0 cube. So in the question they have given the density value. Take this value and what else is there? Area, right? How do you calculate the area? Area you have to calculate pi by 4 dr square. That's the equation. Diameter square. So it's actually pi r square only. Okay. By why it is pi by 4 is, if you consider as d by 2, it will be 4, right? Square is there. So 4 will come here, pi by 4 dr square. That's what here. The diameter is given. You can calculate this value. Area, substitute that area here. Last one is what? U0. U0 is nothing but 16. Why it is 16? The speed of free wind. The first value of the speed they give is the U0 value. Substitute the U0 value, you easily get the answer. Same thing goes for the power extracted also. Half MA into U1. MA is what? This one. This formula is there. Just remember these formulas. Go through them. They are totally of, I guess, 3-5 questions are there. So if you go through this question, easily you will get to know what type of questions are asked. Basically they ask this one only. Just have to remember the formula and do it. So that's all for this video. If you have any doubt, ping me on Instagram. If I have time, I will reply. Thank you so much for watching. Make sure you hit the like button and subscribe to my channel. Your support helps me make more videos like this. And thank you so much for watching. I'll see you in the next one.